Well, welcome back, and hopefully you had an awesome break and you're ready to get back in the groove a little bit. We'll take it nice and easy today and kind of just focus on the word averages. Now, averages have been a key theme for us. We've talked about average rate of change, average value, average velocity, and average acceleration. And our goal today is just to break those words averages down, because clearly they're important on our AP exam, and just really break them down to see, how we would apply each one. So let's go ahead and label number 1 in our book there as average rate of change. Now, this terminology, average rate of change, you've actually been talking about since the 6th grade. Average rate of change is just another way to say the slope formula. And, of course, we don't use y2 minus y1 anymore. We use our function notation. So let's be very clear that our average rate of change is just the slope formula, and our notation is f of b minus f of a all over b minus a. Okay? All right, so let's go ahead and see how we would apply it in a similar example here. Let's say they said find the average rate of change, we abbreviate it as AROC, of course, of our function f of x equals 2x squared minus 2. And notice they're going to give us a closed interval. Okay, this is not a point. It's not in parentheses. It's a closed interval. So all they're really telling you is that this is your a value and this is your b value, and just apply the AROC formula, or average rate of change formula. So the notation our AP is looking for is f of, and you can label them a and b, f of 2 minus f of 0 all over 2 minus 0. Okay, now I don't have any units to worry about in this case, which is very nice. I always start in the denominator, because that's pretty simple, 2 minus 0. F of 2. Now I have to evaluate f of 2 here. All right, so 2 squared is 4 times 2 is 8, minus 2 would be 6, minus, when I plug in 0, I get a negative 2. Notice I keep those negatives there so I don't make any silly mistakes. And I get 8 over 2, which of course is just 4. So 4 represents my average rate of change, or the slope. And I just want to, highlight that word rate. That is telling me to look at the slope. Okay, that nice 4-letter R word. All right, now let's move on a little. The second average type thing we've mentioned is what we refer to as average value. Okay, now this is different from average rate of change. The average value formula was our 1 over b minus a integral a to b of f of x dx. Now I think the average value theorem makes a lot of sense, and hopefully you would agree. What this integral is doing in this section is it's adding up, just like you would add up all the areas under the curve from a to b. Okay, so it adds them all up, just like you do when you find the average of your test scores. You would add them all up, and then you would divide by the total amount of test scores, and that's what this is doing. It's dividing by the difference of those two numbers. So average value should make a lot of sense. Now let's apply that same example on this problem. Our function that we just used above was the 2x squared minus 2 from 0 to 2. And this time, instead of average rate of change, let's apply average value. We'll do the same thing. Okay, so again, this is a and b. So I'm going to say this is 1 over my b minus a. 2 minus 0 is 2. The integral from 0 to 2 of my function f of x, which is 2x squared minus 2 dx. Okay, now we'll simply integrate. I certainly don't need a u sub, there's nothing fancy here. So I get 2x cubed over 3 minus 2x from 0 to 2. And I'm going to bracket that in and leave my 1/2 out front. Just don't forget to multiply by that 1/2. Carefully plug in 2. 2 cubed is 8 times 2, that's 16 thirds, minus 4. Minus, love that 0, 0 plugged in there is 0. I'll get myself a quick common denominator, so of course I'm going to call 4 12 thirds, so that gets me a 1/2 times 4 thirds, or 4/6, which I can say is equivalent to 2 thirds as well. So now we have our average value, okay, compared to our average rate of change. All right, moving on, we've got 2 more terms we need to be familiar with. The next term, 3, is called average velocity. And I think this is pretty straightforward. I know you get all nervous when you see these words, but just slow down and really break them apart, and it makes it pretty easy. The first thing I do, if I see average and not average rate of change, if I just see the word average sitting there, the first thing that pops in my head is 1 over b minus a. Okay, integral a to b. Now here's where you have to slow down. You don't have to guess at this. It tells you who to put there next. Who are you averaging? Okay, read it. It says average velocity. So that's who you would put here. You are finding the average of velocity. Now, you are always going to write this part out. Okay, so that is one option. And now we can, depending upon what information we have, we're going to go as far as we can here. What do you get? So let's use our first fundamental. What do we get when we integrate velocity? Well, we of course get the position. So I would say that's x of b minus x of a. Okay? So if I integrate velocity, I should be getting position. Now, the one thing we do have to watch out for is we have this 1 over b minus a out front. So I need to take that through here as well. So I get x of b minus x of a over b minus a. So option 2, my second option, would be this formula. Now again, I'm not suggesting you memorize the two different formulas. I'm suggesting, write down the average velocity. That's a no-brainer. It says it, average and velocity, and then use your first fundamental. Then, depending on the problem, you'll either use this part of the equation or this part of the equation. Okay, so let's just make a note. Average velocity, this truly is the slope of position. Okay, average velocity is the slope of position. All right, our last example that we need to stick in here before we do some practice problems is the term average acceleration. Now again, I don't want you to memorize anything fancy, just use common sense. We see the word average, so the first thing we're doing is setting up 1 over b minus a, integral a to b. And now be smart, who are you averaging? Well, the next word is acceleration, so that's what's going to go here. Okay, so again, that's option 1, or use your first fundamental. If you integrate acceleration, who do you get? Well, you would get the velocity of b minus the velocity of a all over this number out front, my b minus a. Okay, so again, they're equivalent. Don't memorize, just write the formula down and use your first fundamental. So this is the average acceleration, which happens to be the slope of velocity. All right, now we're ready to apply some problems. All right, so here's our first example. We've got a nice tabular data set, so that on a table, and it says a rocket has a positive velocity after being launched upward from an initial height of 0 feet at time t equals 0. And take notice that we have velocity in feet per second in time. Part A. Approximate 10 to 70 of v of t dt using a left Riemann sum, a right Riemann sum, and a midpoint Riemann sum, and a trapezoid with 3 subintervals of equal length. All right, so we're going to get some nice review in here. First, bear trap, of course. Make sure you watch the bounds. Notice it's not using those values. We strictly say from 10 to 70, and it says 3 equal subintervals. All right, so remember we're going to overlap once, so I'm going from there, switch colors from there, and then in this section, looks like 3 equal subintervals. And let's start with a left-hand Riemann sum and just talk about what we need to show on our AP exam. All right, so my bases are my brackets up there, so from 10 to 30, that would be, I'm going to start with my formula, area equals base times height. I would say that's a base of 20, and I'm going to go to the left-hand side and pick the height. That height is 15. Plus 30 to 50 is a base of 20, the left-hand height is 30. Plus 50 to 70 is again a base of 20, left-hand height is 41. All right, we'll do a little plug and chug, we'll get our answer, not too worried about that. I'm going to move on to the next one. Let's do a right-hand Riemann sum. All right, so again, I'm saying my area is base times height. Okay, now we found something special out. We know all the bases are the same, so I'm going to pull out a 20 for my base, and I'm just going to go ahead and evaluate the right-hand sides. Well, in this blue section here, the right-hand side would be a height of 30, plus in my green section, a right-hand height of 41, and then in my purple section, a right-hand height of 46. Okay, and obviously I would add and multiply by 20. All right, let's go get a midpoint Riemann sum. Same idea, my area is still base times height. Remember, we're just picking the heights in the middle. So I already know that my bases are all 20, so I'm basically going to pull them out, and I just need to go and get my 3 heights. So as I look at my table, I'm going to look at my bracket there, I'm picking the height in the middle. So in between this bracket here, the middle height is 23, 34, and 42. 23, 34, and 42. And again, I would obviously add, multiply by 20. All right, last one is that nice trapezoid. All right, this one we have to slow down on. This one has our goofy formula. It's 1/2 base height 1 plus height 2. And I can pull out anything that's the same. I know every trapezoid is going to have the 1/2, and they all happen to have the same base, so I'm going to pull out the 20 as well. So I basically have to go through and add height 1 and height 2 of each one. All right, now we did talk, last week or so about a quicker method. We know I'm going to have this height plus this height, and then this height plus this height, and this height plus this height. So I'm going to use the first and last once, and then the middle heights twice. So I'm going to have 115, 2 30s, 2 41s, and 1 46. All right, and again, if you want to list them all out, that's totally up to you. Listed, I guess, to be clear. You could have had the 1/2 and 20 times. You have 15 plus a 30, plus a 30, plus a 41, plus a 41, plus a 46. Okay, and again, all I did was I say, okay, I know I have 15, I'm going to have 2 30s, 2 41s, and a 46. All right, part B. Probably one of the most important and easiest questions, I think, is to explain the meaning of the integral. All right, now, I want to be very clear. All right, we just start with the integral, and you're explaining what you get. So the integral from 10 to 70 of v of t dt represents the change in... Now just, again, use common sense. When you integrate velocity, who are you getting? Use your first fundamental. If I integrate v of t dt, according to the first fundamental, I get the position of 70 minus the position of 10. And that's what goes here. Represents the change in position. If you integrate velocity, you get position in, now let's talk about our units. If you had feet per second and you integrate, you're getting the position in feet from t equals 10 to t equals 70. Okay, and you have to have those units on there as well. So I tried to highlight the 3 things you have to have. Who do you get when you integrate it? In what units? And talk about the bounds. Remember, when you integrate, you lose the per. So if it's feet per second, you lose the per. All right, question C. Find the average acceleration of the rocket over the time interval 10 to 80. All right, now don't be scared when you see this question. The key word that should be jumping out the page is the word average. And since it doesn't say average rate of change, I'm going 1 over b minus a. Now, here's my a and my b, so I'm going 1 over 80 minus 10, which I can do in my head is 70. The integral from 10 to 80. And again, just read, who are you taking the average of? Okay, it clearly says the word acceleration, so that's what I'm going to put here. Okay, now if I had a function to integrate, I'd be done, and I could actually integrate something, but I don't. I just have this table of values. So I'm going to apply my first fundamental. I'm going to say this is equal to, what do I get when I integrate acceleration? Well, I get velocity, of course. V of 80 minus v of 10, all over that b minus a out front, so all over 70. All right, now let's talk units. Acceleration, okay, if velocity is feet per second, when you derive, you add on a per second. So this is feet per second squared. Just want to be clear on that. Velocity is feet per second, so acceleration is feet per second squared. If I integrate acceleration, I'm going to lose my per second, so I'm going to get feet per second. But now I'm multiplying by a 1 over second, so I'm going to get back to feet per second squared. So my units on this answer should be feet per second squared. Let's go look at the other side of the equation. V of 80. I can easily find that on this table. V of 80 is 50 minus V of 10 is 15 all over 70. Now let's talk units. The 50 minus the 15 is feet per second. Divided by 70, 80 minus 10 is 70 seconds. That's getting me feet per second squared, which is the same thing I should have got here. And if I subtract, that's 35 over 70, or 1/2 feet per second squared. All right, next question. Instead of a tabular question, we have a nice function here. The velocity of an object traveling is given by this function. Part A, what is the average velocity of the object from t equals 0 to t equals 3? All right, so let's slow down here. The second I see that word average, and again, it's not average rate of change, I'm going 1 over b minus a, so 1 over 3, integral 0 to 3, and I'm averaging who? Velocity, so I'm going to put that function in there. Okay, now, we could be smart here, and we could say, okay, let's apply our first fundamental. If this is velocity, I would be getting the position at 3 minus the position at 0 all over my denominator of 3. Now, which one happens to be more useful here? Do you know anything about the position? No, they don't tell you any of that. So, in fact, you can't use this whatsoever. All right, so again, you've got to use common sense. I mean, I write them both out, but then I'm only using one of them. I don't know anything about position, so that's not helpful. So this one I have to slow down and integrate. Oh, it's been a little while, so I'll walk you through it one more time. I know it should be a no-brainer you need u sub because this is inside something. So u equals 3t minus 1. My du equals 3 dt. So I get du over 3 equals dt. All right, so I got this nice 1/3 out front. Leave your bounds off. Remember, u sub, u bounds. I'm going to say this is the cubed root of u. And in place of this dt, I'm putting my du over 3. All right, so let's go get those bounds. If I plug 0 into my u, 3 times 0 is 0, minus 1 is negative 1. If I plug 3 in, 9 minus 1 is 8. Okay, I can pull out this 4 over 3 out front, which is going to give me a 4/3 times 1/3, which is 4/9. And I'm integrating from negative 1 to 8, the u to the negative 1/3. All right, just brought that upstairs. All right, so let's go ahead and integrate. Remember, we add 1 and divide by that. So if I add 3 over 3, I'm going to get u to the 2/3, divided by 2/3, or times 3 halves, from negative 1 to 8. And don't forget you have this 4/9 out front. So again, I'm going to multiply this junk out front to clean it up and say that's 12 over 18, u to the 2/3 from negative 1 to 8. Okay, some of us got sloppy. Make sure you're saying it's upper minus lower. So I can reduce that. Let's see, 6 goes in there. That's 2/3. If I plug my 8 in, I get 8 to the 2/3 minus negative 1 to the 2/3. Okay, cubed root of 8 is 2. 2 squared is 4 minus. The cubed root of negative 1 is negative 1. Negative 1 squared is 1. 4 minus 1 is 3. Times this 2/3 out front gets me a nice 2. So I know that my average velocity, that's what we were finding there, is 2. All right, now let's go ahead and answer part B. Same idea, what is the average acceleration from 0 to 3? Okay, so again, I just want to be clear, it said average, so that's my 1 over b minus a, I believe it just said 0 to 3, so 1 over 3. And don't guess, it said average acceleration. Okay, now I'm going to do this two ways. I'm going to use my first fundamental and say the integral of acceleration equals the velocity at 3 minus the velocity at 0 all over 3 minus 0. Now, which one would make more sense to use? Do you know your a of t function, or do you have your v function? Well, I know my v of t function, so I can just evaluate v of 3 minus v of 0 all over 3 minus 0, because we said v of t is equal to 4 over the cubed root of 3x minus 1. So I'm going to use that and evaluate. So I'm going to go v of 3. If I plug a 3 in, I'm going to get 4 over 3 times 3 is 9 minus 1 is 8, so that's 2. And I know v of 0 is going to get me 4 over, let's see, the cubed root of negative 1 is negative 1. So that's a 2, and that's a negative 4. So if I evaluate that function, I got v of 3, which is 2 minus negative 4, all over 3. So I've got 6 over 3, which is equal to 2. So I think that does it for us tonight. Really watch the words average rate of change versus average value, average acceleration, average velocity. Well, look forward to seeing you tomorrow. Have a great night.